Hello, 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 everybody, and welcome to TGI Kubernetes. This is episode 105. I am your host, Joe Beda. I am a principal engineer at VMware. Started a company around Kubernetes and sold it to VMware a little over a year ago. For those who are not familiar, TGI Kubernetes is a weekly-ish thing where me or one of my compatriots uh, starts streaming, plays around with, talks about what's happening in the Kubernetes ecosystem, starts playing with some new technology, and we explore it together. I think we tend to go long because this is all unfiltered. A lot of times I'm learning stuff for the first time, and and so that's generally what we do. And I like to start out by saying hello to everybody who's joining me. When we first did this, I hadn't realized that this is like the worst time, to actually hold one of these things because so many other folks around the world, it's Friday night or Saturday morning or the middle of the night or what have you. But thank you everybody for joining me regardless. And so, I'm always, amazed with the representation from around the world. So first of all, Lamati, who's I think hasn't missed an episode. Thanks for joining us. Suresh, good to see you. Walid, good to see you too. Marcos from Boulder, good to see you. And then George is on the line for a bit, helping to do chat and stuff and around the behind the scenes. He also this is George Castro, who's big in the Kubernetes community. Also helped to pull together a bunch of the links that we're going to be going over for the news of the week. So thank you for that, George. Tim from San Francisco, Martin from the Netherlands. Pruthvidar from Seattle, good to see you. Ian from Cardiff. Evan, compatriot from Bellevue. Evan, do you want to do one of these ones? We can rope you into it. Nuno from Portugal. Yatin from Ashburn, Virginia. Philippe from Paris. Vamshik from India. Morteza from Tehran. Wow, good to see you. Derek from San Mateo, Aman from Bellevue, Santosh from Philly, Scotty from Pensacola, Dublin, Tega, good to see you. Paul from Brisbane, another yarn from Bellevue, another person from Bellevue. Gregor from Switzerland. Joe from London, Chen from Kenmore. So a lot of folks from around the Seattle area. Hopefully folks that are working on Dapr, which would be great because I'm going to need all the help I can get. So if you work on Dapr, feel free to identify yourself and we can start throwing questions at you as I start screwing stuff up. All right, so let's jump into things. And I love to, we start out here. Okay, Yaron. Yes, Yaron, good to see you. One of the maintainers, and also sent me some of the pointers of where we're going to start here. So let's go through sort of our news of the week to begin with. Now, one of the things that we do here is we crowdsource notes. And so if there's any notes or links or stuff that you want to share, feel free to edit this document here. You can get to this at, let's see, it's, George, can you put the link in there to the HackMD? And then we copy and paste this into a repo, link to that repo from the description of the video so that this stuff all kind of ties together. So if you're watching this after the fact, you can definitely see it there. All right, so stuff that's going on. So Kubernetes 1.18 is percolating along. We have a code freeze on March 5th. We're on Alpha 5, and we have this amazing, this is not the full changelog. We have a changelog that's actually pulling together sort of what are the new things that are coming through. So you can start looking at all of the changes, and hopefully things are starting to settle here a bit. So just be aware if you're interested in sort of the cutting edge of Kubernetes, that stuff is coming along. And let's see, is it, yeah, it's capturing the right part of the screen. OBS was doing something funky to me. I got like a new microphone and it crashed and I had to reboot. So another thing that's going on here is, let's see, we have, okay, so this is fascinating. So this dates back, honestly, to the first integrations of Kubernetes with Docker, is that we wanted to have this idea of a pod. A pod was a whole bunch of Santosh, good to see you. Yeah, if you've worked with EKS, you can definitely adapt and learn this stuff. I try and keep stuff clear Kubernetes. So yeah. So anyways, early on when we were integrating with Docker, we had the idea of the pod. Pod is a set of containers that operate in a shared context. Those containers are all equal, or at least they were. Now we have init containers and we have official support for sidecars coming, so all sorts of good things coming that way. But Docker didn't understand what a pod was. And so we needed a thing that would sort of bring up a bunch of context for a pod, but wouldn't actually predicate on any single thing. And so we created this container image that does nothing like come up and pause. And it's called the pause container. And it's been stuck at version 3.1 for a long time. And apparently we just upgraded this to the next version. And we're scared because this is going to be, and so I don't know what the exact changes are in 3.2 that motivates this, since we changed the build. So something happened and we have a new version here, and this is going to be quite the effort to get everybody upgraded to the latest and greatest version. I think we should understand, and I don't understand all the implications of what it means to keep running the old version on accident. So that's something that I think we should probably, as we push this out, understand what's going on there. But this is those types of things where it's like, oh, it should be easy. Let's just rev it. No, it's never quite that easy. Never quite that easy. Let's see, another week, another pile of point releases. So this is just a bunch of backports to the versions that we're supporting, 17, 16, and 15. And then you can actually go through and click through here and see the individual things that got cherry picked. There's like some, relatively minor stuff is what it looks like. So nothing earth shattering, it looks like. And let's see, and then we have, oh, this is really interesting. There's a KEP on starting to create a KEP, a Kubernetes enhancement proposal to start creating a LTS version of Kubernetes, which is really great because I think Kubernetes moves super duper fast. And we support 3 previous versions, but we release 4 times a year, which means that many, many users are on this sort of upgrade treadmill. Very much looking forward to having something that's boring and stable that we can support for a longer amount of time. I think that makes sense as we've moved more of the exciting stuff out of core. And so this is a great effort to actually pull together all of the ins and outs and implications of actually doing an LTS version and how that works. So definitely check this out if you're interested. Okay, well, it says that the pause 3.2 is built with the correct architecture metadata. Oh, okay. So this means that you can pause, eventually we can pause on all sorts of architectures, not just x86, huh? All right, so that's Kubernetes project itself. Other stuff happening around sort of the Kubernetes cloud native ecosystem is Jurgen did a look at Kepton. I haven't looked at this. Looks really interesting. This is a continuous delivery framework for Kubernetes. And so, understanding sort of like, and this is one of those things where these things all blur together. We have CI/CD, which is continuous integration, continuous deployment, but then there's also continuous delivery, which is really thinking about the entire cycle. And so this looks super interesting. I'd love to dig into this. So this looks like a great blog post on this. And it's all event driven. I'd love to start taking a look at one of these things and from the point of view of like level set versus edge triggered, right? Something that actually borrows a bunch of Kubernetes ideas, but looks at it through the lens of deployment, not tied to a single cluster. So that I think would be super interesting. This is great. So this is a post that somebody posted to Kubernetes. This is super scary. Was mucking around with some stuff, accidentally deleted everything, all the pods on a production cluster, and 2.5 minutes later, everything was back up and running, which is really, really crazy. And so I think it just goes to show that, the self-healing aspects of Kubernetes, is coming into play here. If they deleted all their deployments, they might have had a worse time, unless they were, essentially following a GitOps source of truth model, and they actually were able to redeploy from a known good state. Or if they were using something like Valero, that would have saved their bacon too. Very cool. here's somebody writing an article talking about, so this is LJ Miranda here, talking about how when they were learning Kubernetes, things really clicked when they started thinking about deployments and services versus focusing on things like pods and nodes. And for me, this is really fascinating because I'm what I like to call a depth first engineer. I want to understand things super, super duper deeply and then sort of build up layer by layer there. That's just sort of my way of learning things. But there's a lot of other folks that are much more task oriented, like, how do I get my job done? Let's start with that. And then I'll learn the details if I really need to. And it's fascinating to me to see that like different people learn different ways. And when we were working on Kubernetes Up and Running, the book that Brendan, me, and Kelsey wrote, we also took that take on that approach that we started with some of the more useful stuff later, and then you get into some of the more esoteric sort of details over time. And so we tried to think carefully about how we introduce these topics so that you didn't feel like you were swimming in details. All right. So let's see. Larry from Johannesburg, good to see you. And then Steve, good to see you, Steve. Steve is one of the maintainers on Contour. And there's some good discussions going on in the chat there. All right, so other stuff. Apache Flink, which I've never used, has native Kubernetes support, which looks really cool. It's in beta. Flink is a sort of data processing framework that runs on all sorts of different clusters. Jonathan Simons has an article of, this is on the Minio blog, why you can't containerize the storage appliance. It's really, I think, talking about the move from these appliances that sort of operate on the network as like a box to things that are more API driven, more scalable, and that's what you need to be more cloud native. So some interesting sort of perspectives coming from sort of the storage space going on there. And then this is really cool too, is that the HA proxy folks, I consent to cookies, let's go, essentially went through rolling updates, but then showed how you can do a blue-green deployment by essentially redirecting ingress, which is really cool. I don't think they took it far enough to start thinking about like, well, how can we use controllers or other systems to actually help manipulate that ingress, which seems pretty cool. And so there's a set of systems, things like Flux, that can actually help with some of that. So pretty cool. And then update from George on our 100th episode, which was, I guess, 5 weeks ago now, since this is episode 105. We identified a bunch of folks we were going to send t-shirts through for. He's working diligently to get that going. These things are always more complicated than you want them to be. And so please be patient if you have some of those coming to you. All right. All right, let's get going. So what the heck is Dapr? I think this is really fascinating because we're starting to see a class of projects which are building on top of Kubernetes, which are much more curated in terms of how your application code interacts with a runtime. And those runtimes are being delivered as a set of sidecars that run next to your workload. And I think Dapr is a great example of this, where there's some architectural patterns, they get captured, there's great support, and then they sort of like wrap your code with that so that you don't have to implement a bunch of this stuff in your code. You don't have to actually go through and worry about, do I have a compatible library that's interacting with this other library across languages and stuff like that. All that runtime stuff runs as a sidecar for you. And so another similar system that we're not going to go deep in today from the Akka folks, and so Akka is a Java framework for doing a bunch of streaming stuff, is this thing called Cloud State, which is another sort of entry in this space where essentially thinking about serverless, but actually providing more infrastructure, more opinion about how these things deal with state, how they deal with each other. And so these are, I think, a couple of ways to look at some of these problems, which is really cool. Let's see. So Vamshik is there a way to get access to HackMD documents used in the TGI podcast? Well, you mean this thing here? So I think George further up should have. Yeah, it's tgik.io/notes if you want to help out there. So if you go there, that'll take you to the to the HackMD if you want to actually see what's happening there. All right, so yeah, we're not going to go into cloud state, but it's interesting that we're starting to see a class of systems like this that I think are really, really interesting. Um, and then Parthabon saying, what is the Google OSS equivalent to Dapr? I don't think that it exists. I think Google's been putting a lot of effort into systems like Knative and Istio. Istio provides some of the security aspects that I think we're seeing with Dapr, and I want to dig into that a little bit. I've just got a hint of it reading the docs. And then there's Knative, but Knative is more of a serverless toolkit. It's not a it's not sort of an opinionated sort of architecture thing like something like Dapr or Cloud State. I think one of the interesting things, and I know talking to the Cloud Native, I mean to the Knative folks, there is some talk about Knative supporting having more than one container as part of your runtimes in Knative, and that might be an interesting way to start slipping in more opinionated sort of helper runtimes with something like Knative. So that's something that I think is going to be really interesting. I think one of my fears when we look at these systems is that they create silos and there's a lack of interoperability with other systems running on top of Kubernetes that may not be part of Dapr that you want to communicate to. So that's something that I'm going to be keeping an eye out for as I actually look through this stuff. Yeah, so let's go to the home page and we'll see what it says. An event-driven portable runtime for building microservices on cloud and edge. I mean, that's kind of generic, so I don't even know what that means. Building blocks, open API, no limits. So that means any programming language, cloud or edge, and it's open source. So that's all good stuff too. We could watch a video, but you didn't come here to watch a video of me watching a video, so let's not do that. Okay, so distributed app challenges. So incrementally migrating to microservices, the runtimes being pinned to the language, doing event-driven and state handling are difficult at scale. And then many runtimes only target specific infrastructure platforms with limited code portability across cloud and edge. This one I'm a little less sure about, I got to be honest. And I think this is something that we've seen Microsoft do in a couple of different places. We see this with Dapr, we see it with OAM. It's this idea of like, hey, I want to target multiple substrates. I think there's cases where this actually makes things more complicated and it restricts some of that interoperability between different frameworks that might be running on the same infrastructure. And so my take on it is, and I'm biased here, but like just write the thing to Kubernetes and like go from there. But I think different folks are looking for different things here. I generally want to see things that are more incremental and provide that ability to interact with in a fine-grained way with other things running on the same cluster that may not be dealing with the same runtime. All right, so select your OS, starts with Windows. Oh, that's cute. Okay, I can do a wget here and then do Dapr. But I'm not going to do that. We're going to actually go to the docs here. We're going to go to GitHub. We're going to start looking at this. There's an overview here that I think goes into some more depth about what exactly that we're talking about here. So this is the docs that I want here. Okay, so service invocation. So how do you do service-to-service calls, retries, remote? So this is a lot of that sort of some stuff that shows up oftentimes in service mesh types of things. How do you create resiliency at the sort of service-to-service layer? State management. This is about how do you actually manage state in a distributed way without having to go crazy and write a lot of bugs. So it's like understanding a set of patterns and how states interact with those patterns. And so I'm going to be interested in looking at that. And I think that's the type of thing to sort of compare and contrast with something like Cloud State, because that really is Cloud State's focus. Publish, subscribe messaging between services. So interacting with queues, things like Kafka. Oftentimes, and this is very confusing, folks will talk about this as being reactive programming, where you're actually talking about queues and your message passing between different actors and they're reacting to those messages. That reactive programming model is different from reactive, the UI thing from Facebook for browsers. It's very confusing. It confuses me also. Event-driven resource bindings. Resource bindings with triggers builds further. So I'm not sure what this means, but Oh, so this is actually being able to send and receive events from external resources such as databases, queues, file systems, etc. Distributed tracing using the W3C trace context standard. I wonder how that applies to the open telemetry stuff. And then an actors pattern for stateful stateful objects that make concurrency simple with method and state encapsulation. So this is part of that sort of, message passing stuff. And so the idea is that any application code, HTTP gRPC, there's this runtime here. So your application code, the bulk of the functionality comes from a sidecar, not from your application code. And then this can run across a whole bunch of different infrastructure. I think it's cool that they put AWS and GCP on there. I guess via Kubernetes you can get support there, but I'm guessing there's no sort of native support going on for any of these yet. So yeah, I mean, I'd love to know, like right now it looks like there's a local development experience and then there's an experience on top of Kubernetes. I wouldn't be surprised if Azure has some plans for this being natively supportive. I think it's going to be interesting to see over time if there's some push-pull about like, hey, we can't add feature X because if we add feature X, it won't be available on the Azure version. That sort of push-pull is definitely something that we've seen in the Knative world. So yeah, so all of that stuff, that goodness comes in a sidecar, and then your application runs, and that runs in a pod. And so this is a great example of where that pod concept really comes into play for doing some really interesting stuff. And then here we can say run it on local, or I can run it on Kubernetes. Sweet. And so let's see, that what we're going to see is that there's a sidecar injector, which probably is a mutating admission controller webhook. There's the operator, provides services, provide first-class integration to launch Dapr as a sidecar in the same pod. So I wonder what the operator does that's different from the injector. And then there's Sentry, which is a certificate store for doing so this is interesting, and this is a place where I think there's an opportunity. I did an episode on Spiffy the other day, Spiffy Inspire. This is a place where the way that TLS certificates are handed out, the way that communications is actually validated, will probably only work between Dapr and Dapr. And if you're talking to stuff outside of Dapr, you really miss out on this stuff. And so this is exactly why we created Spiffy. And so I would love to see something like Dapr really take advantage of Spiffy so that we don't actually create sort of this Dapr world with secure communication, and then when you go outside of it, you can't do it. That's, really looking at how do we actually create interoperability there would be really, really good. I mean, this is good stuff. Don't get me... Okay, so it looks like the controller is for config updates. Okay, to the sidecars. Yeah, I mean, this is good stuff. I think doing MTLS, doing a hosted CA, doing rotation, that's all great. I think that there's a huge opportunity to create this identity control plane that is wider than one single runtime. And so that's something that I think I'd love to understand. There's this self-hosted thing where you can have the Sentry talk to some other thing. Oh no, this is Kubernetes. So it stores in a Kubernetes secret. Yeah, so that's something that I think I'd like to look at, and I think that I think hints at maybe one of the downsides of these systems where these things are sort of their isolated environments. So Chen is asking, does this mean that Dapr cannot work with a service mesh? I don't know. That's a good question. What happens when you're running Dapr on top of something like Istio? Do you get like double MTLS, right? Where you have Dapr doing stuff and then you have Istio doing it because it's happening at different levels. What happens when you're running both sidecars at the same time? Okay, so you'd have to turn the MTLS off in that case, and then you're relying on that. But one of the problems with Istio specifically is that it does MTLS, but the identity of who's calling you when you're actually getting an RPC call, that identity doesn't get passed on to the application. And so that means that you get less application context in that case, or at least last I checked, it didn't get passed on in a trusted way. So that's something that's interesting too. All right, so that is the overview. And the operator propagates configuration updates to Dapr sidecars. This is really interesting. I think that there's room, and this is one of the things that exists in the Spring community, to actually think about configuration, versioning, propagation is a first-class system that actually gets extracted and separated from a bunch of these other things, both for applications and for infrastructure type of stuff. I know that Google, when I was there, had some really interesting systems for being able to propagate configuration changes, but also viewing those configuration changes as similar to a code rollout where you want to have CI/CD, you want to do canaries, you want to look for signals, or sometimes you want to try and push things as fast as possible. A configuration versioning rollout system would be really, really cool to see somebody build. All right, cool. That isn't sort of tied to one of these things. Okay, so let's get into the details here. So there is a getting started link that we have here. And it's like, let's deploy it in Kubernetes. There we go. Okay, boom. This is the environment setup that we want. So the first thing we do is we get it. All right, so we're getting an install script. This is a little scary. Brew search Dapr. Let's see. No, it's not there on Brew. So, okay. So this is like, this scares the crap out of me. I got to be honest. Like this, like, let's install some random, well, at least this one. WG, curl .l. Okay. Okay, so let's do, oh, I haven't launched code in a while. Let's see what it actually does when I do this. All right, it's probably going to want to update some stuff. Okay, so let's look at this. What are we doing here? Okay, this is a system info, verify supported, checked whether we got that, check HTTP request CLI, get latest release. Okay. So this is getting the latest release. One of the things is that the Dapr team released something, I believe, about 3 or 4 hours ago. This is 0.4. And I think I was given advice to try and do 0.3. So let's see if we can actually make sure that we install 0.3 just so that we're not super bleeding edge here. I don't want to get myself into a bit of a bind here. So this is going to run as root. This is going to curl a bunch of stuff, reinstall it. Okay, releases. And then where's it? So why does it need root? Download the file, failed trap, install completed. What's install file? Failed. Run as root. Where's the installer? I want to install it locally. Okay. So we're not gonna use the install script. We're gonna hack around that. Okay, Aman says I should try the latest release. Okay. Okay. We recommend 0.4. All right, I'll do 0.4. All right. I don't wanna get y'all github.com Dapr. Yeah, I just wish, I mean, if homebrew or, so let's see. So we have Dapr. Apparently only one person is here. Everybody else is private. They're not talking about that they're involved. Let's see. So we have releases, and we have here a bunch of stuff. And then what do we get? There's a bunch of assets. And we need, let's see, which one are we looking for? Placement, operator, injector, Dapr D. Where is this thing pulling from? API repos, releases, getting the latest release. And then what's the release URL? Oh, I see. Okay. Releases and then request CLI. Which artifact is the CLI? Is that Dapr D or is that? I'm sorry, I'm a little confused here. Give me a second, all. Awk. Oh, there's a CLI repo that's different from Dapr. Ah, that makes sense. Okay. There's Dapr R, CLI. There we go. 10 releases. Oh, not only do I want 4.0, I want 4.1. Okay, cool. So here's the assets, and here we can get copy link address, curl. All right, cool. Tar, X, CVF, Dapr, Darwin. What do we got? We got one thing. Copy, Dapr to thin Dapr. There we go. Dapr version. CLI version, runtime version. Sweet. Okay, so we got that up and running. And I think that shell script, that's essentially what it did. Oh, look, hey, there's the thing for not using the shell script. I should have just followed those instructions. I'm an idiot. Sorry about that. All right, and so now we're going to do a Dapr init. So this is really interesting, is that this will actually install it into your cluster. I'm very unsure about these things because like this is going to do a lot of stuff in my cluster. I don't know what it's going to do. I like to do sort of like examine the YAML, stuff like that. You know, as we look at things like CNAB and different ways to install stuff. Oh, Dapr init will install it locally on the machine. Okay. I don't want to do that. Let's install it in Kubernetes. Okay, so we have to do Dapr init Kubernetes. Like, especially as we start thinking about air-gapped version things, all that, you know, it starts to get a little bit confusing there. So, okay, so yeah, we need something that'll actually sit in the middle and sort of like, because like my favorite tool for this is, and you know, I've talked about this before, is that there's cap. And so cap is a, it's this way, it provides you a way to install stuff, and it gives you a UI that looks like, you know, a Terraform UI, where it's like, here's all the stuff I'm about to do, here's the namespaces I'm going to be impacting. And so having that diff and having the ways to be able to filter it as you go makes me feel a lot more confident about what the heck's going on here. But let's, so I have a kind cluster with one node, Dapr init, Kubernetes. Let's see what's going on. Deploying the Dapr operator. All right, well, that wasn't hard. All right, and then, so it's installed, so I can do cube control, cube, get pods. Okay, that's interesting. So this ran this. So if I launch Octant here, let's see what we got going on here. So we got, so these things are running in my default namespace, which is really interesting. And so with the operator, sentry, and the injector, and what did it do with respect to, so let's look at the operator, which I assume was the first thing here. This thing, let's see, does it have a service account? Okay, so this is the operator service account. So, okay, so it created this thing here, and that's the service account. And so, okay, this is, I need to send this to the Octant team. It would be cool if I could actually, from a service account, be able to back propagate which roles and role bindings are actually being used there. So, okay, so I don't see any roles or role bindings. So maybe this is cluster roles. Cluster role bindings. Okay, there we go. Okay, so this is something that I think is a little bit weird, is that it's installing it into the default namespace, but then it's giving it essentially cluster admin and secret reader. Yeah, so this thing, I mean, it's running as root on your cluster, which is okay, but I think, you know, I also think it's really interesting to see systems like this to be able to run in sort of a local mode where, hey, I'm only running this thing where it's operating within a single namespace. And I definitely think that, you know, when you're installing stuff, you know, like this, that you understand that this is something that actually is hitting your entire cluster, and it's threading itself through. So that's something to keep in mind there. Okay, so there's also some Helm stuff that you can namespace it with. Okay, interesting. Cool. All right. Very cool. Okay, so we are so we have stuff up and running, and it installed the let's see. So we have deployments here. We have the placement sentry and the sidecar injector. What does placement do? I wonder what that does. Okay, well we'll play with it and we'll actually see where we get with this. Okay, so we're up and running. Oh, here's using Helm is the advanced thing. So you can add the Helm repo. You can go and do a Helm install, and Bob's your uncle. And then we can look at the Helm charts. And if you want to like gouge your eyes out, we can look at the templates, right? Gotta love using Go templates with YAML. Okay, let's see. So that's okay. So we're up and running now, which is great. And then there's a set of samples that we can go through, and we have a sample version, and we can fix the links because I think the getting started in the samples that I was pointing to here were the 0.3 ones. So we definitely want to be looking at the 0.4 one since that's what we're going to be doing. So we have the runtime, the sample version, and I believe there's like a sample repo. Yeah, this is a sample repo. So let's go through and clone this. Or an octane in the background. Git clone samples. Okay, cool. All right, so let's look at hello world. Let's see. So this thing is all running locally. We didn't set up the local stuff, so we're going to skip this and we're going to actually go to hello Kubernetes one versus hello. We're going to jump right into it. So there we go. Okay, so we have a pod that has the operator, and then the operator is so I wonder, is it really an operator? Because is it the one that actually launches the pods? I don't know. Let's actually figure it out. So we got it set up there. We need to create and configure a state store. Okay, so let's go through and do. Okay, do I have? Is this Helm 2 or Helm 3? And I don't even have Helm installed because I rebehaved my machine a little while ago. Let's go through and do. Yeah, is this Helm 2 or 3? Can you let me know? Brew install Helm. Let's see if that gets us Helm. Okay, Helm 3. Okay. When I do brew install Helm, I wonder what it's actually going to do. Okay, installing Helm 3. Okay, there we go. Sorry. I don't read. Okay, so yes. Okay, I'm doing exactly the right thing. Sweet. There we go. Let's see, deleted formulas, Python 2. There's a bunch of updates. Holy moly, I got to get my act together. All right, let's see, Helm. Okay, sweet. Okay, so we can do Helm install Redis. Failed to download Redis. Oh, Helm repo update. No repositories found. Okay, what did I do wrong there? Docs, roadmap. Wait, do I have to do Helm? I don't, is that going to install? What does Helm init do? Source. So it's set up, okay, so do I have to do a Helm init? You need to add the stable repos. Okay. How do I install Helm, initialize? Okay, so we have to do this. Gotcha. Weird. Okay. Helm install. Okay, we're going to do that in the background. And then I can do, let's see, what is Redis password? Okay, to get your, okay, that's in a secret. And then I can do Redis CLI, brew, install Redis CLI. Redis, does it come with the CLI? I don't know, I don't have it installed. Connection, wait, okay, so an error occurred forwarding, blah, 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 error forwarding. It looks like maybe it got attacked together. It says connection refused. Is this what we're talking about? Port forward, 6379, SOCAT, command returns. Oh, we're in a crash loop back off here. Cube control logs. Cannot open the append only file. Permission denied. Okay, let's switch back to Octane and see if we can see what's going on here. You forgot? No, I did port forward. It's running. Let's see, where's the port forward? It's running up here, and it's running in the background. So we're port forwarding. That's an error from the port forward because the thing's not running. Let's see. So we have pods. Do we have Redis? We have the Redis master 0. These things are. Oh, you know what the problem is? It's a yeah, Redis. So it's in a crash backup. So I think, you know, what did I do? Logs, right? It's saying can't open the append only file, permission denied. So what's actually happening here is, I believe, let's look at these pods. We'll look at Reddit master. Container environment, volume mounts. I think the data path is probably not getting mounted somehow. Because if we look at, there's a persistent volume claim. Is that what's going on? All right, let's do Redis, Helm, chart, kind cluster. All right, shoot. I think that's what's going on, but I'm not 100% sure, and I want to get past this so that we can dig into stuff. Okay, let's look at cluster overview. Do we see volumes? Nodes, stateful sets, configure. Okay, PV claims, bound, read write on. Okay, so what's going on here? Okay, so weird. Okay. Probably wrong context. K9S supports RBAC reverse lookup. Okay, cool. Yeah, sorry, all. I'm trying to read and see what's going on here. So this is a can't open append only, permission denied. That's not a Kubernetes one. Here's somebody trying to do it. Do y'all know what's going on here? short of actually. All right, let's, my guess is that the volume is not getting actually initialized with the right permissions. So that's what's probably going on here. Cube control, get pods, okay, cube control, exec. Okay, so it's booting up and then it's crashing right away. With crash loop back off, what the heck is going on here? And we're actually saying that the configuration is right, but something is wrong with the container. Let me think here. What's the easiest way for us to do this? Yeah, edit the command to get it to boot so you can get a shell. Yeah, I think that's probably the right thing to do. Okay, so cube control edit stateful set Redis master, and then let's see, we have the password file. So this is actually blah, 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 then run. arg0. So this is command. Where's the, sorry, I'm just trying to, yeah, that's what I'm thinking. Replace all of that with sleep. Oh, and there's a liveness probe. We're going to delete that. Well, that'll, at least it'll be there long enough to, that should be good. Okay, command. Okay, let's see if that fixes it. You probably want, you think I want bin bash dash c sleep? Let's see what happens. What's the worst that happens? Same thing. It should have recreated that. What did I do? I edited the stateful set. Cube control. What's the stateful set doing? Just disable persistence. Set persistence enabled false in the, yeah, let's go ahead and do that. We'll just work in memory. Okay, helm, delete. So is what? How do I helm uninstall? Redis. Okay, so let's do helm install Redis. Can I just do set persistence dot enabled equals false? Yeah, I think it's something with the PVs and permissions is what's going on here. We'll go through and do this. We'll kill and restart the port forward. And then we'll try and run the CLI. No. Ah! All right. Did that actually... All right, this sucks. This sucks. Trying to think what is the... What happens if I do? Oh wait, what is it? Oh, I can't change that. That's right. Shoot, so I'm gonna have to edit the stateful set. Sorry all, this is not what we planned on doing. And I usually try and have a backup plan that is like a more normal type of cluster, but you know, this stuff should work in something like kind. All right, let's see. So that's edited. All right, let's. Helm install Dapr Redis f Redis override.yaml. What do I put in the Redis override.yaml? Is that where I can do the? Did my set not actually show up? The URLs don't work here, unfortunately, and so you can put them in the if you want to put a URL, send a URL. We can put it in the show notes, and I can copy and paste it from there. All right, so what are we doing here? So let's see. Okay, so we're going to do a kube control. Okay. Sweet. Okay, so this is super duper simple Redis. Okay, let's just go and do this. Touch redis.yaml. Cube control or thank you, sir. Let's see if this works. ls is it deploy? It's deploy, yeah. Deployment in service. Oh yeah, the PB paste on the Mac for sure. Okay, so let's see if these things are creating. We're downloading stuff. Okay, cool. And so now we should be able to, let's do the port forward. And this thing is called Redis Master also. There's a service, so I will do that. Oh, we're already doing it. Let me restart that. Okay, and then I can do Redis CLI. Oh, and do you know what the password is? Okay. Get foo. Sweet. All right, no password. All right, thank you so much. Okay, that's awesome. That gets us up and running here, and we all learned a lot. And sorry I didn't sort of chase that one to ground, but I think, you know, at this point we're I don't want to get too when I lost my place on the samples, but well, we're gonna samples 4. Hello Kubernetes. Okay, that was harder than it should have been. Add the keys to the redis.yaml file in the deployed directory. Okay, so let's look at sample cd. All right, we have a deployed directory here. So samples, hello Kubernetes deploy, redis.yaml. Okay, your Redis host here is going to be Redis master, right? And then the password, we're going to set that to a string. You know, I quote these things because, you know, YAML, state store. Okay. Okay, so this is a Dapr CRD called component. And it is called, so it's called state store. It's type state.redis. Okay, so there's this generic config here for with Dapr where it just has component config and then it's just key value pairs with a type on it. Okay. It's kind of like a config map by another name. Okay. And I wonder how it differs from config maps. Okay. And then we apply that. Okay. Cd deploy, cube, control, redis.yaml. And that thing gets created, and I wonder, does any magic happen? Right, if we look at Octane here, custom resources, we have components, state store. Cool. Nothing exciting going on there. There's the YAML of it. We need to find out, okay, and then there's a configuration, and the configuration, let's see, HTTP pipeline, MTLS, allow clock skew, tracing. Okay, so that's the configuration for everything. Okay, cool. Okay, so let's go back to our tutorial, and this will deploy our, okay, so, and then we're going to deploy the node.yaml. So let's see what's going on here when we do that. Well, what is in node.yaml at this point? Okay, so this is a Kubernetes service called Node app that is just going to Node, and it's a deployment. The deployment has some annotations around Dapr, and then it's just a simple container. Okay, so this is serverless in that it doesn't handle sort of source to code. That's still left as an exercise to the reader to have their own thing. It's really a runtime that way. So this isn't really what you'd call serverless, but I think we could probably definitely like, let's see. Yeah, we can definitely go through and, you know, this might work with a serverless type of framework, but it assumes that you have, okay, and then we only have one replica here. So I wonder if that, serverless but not Dockerless. It depends on your definition of serverless, right? No, okay, so this thing will actually create the deployment. We're not doing anything fancy there. But what should have happened here, and we're going to look at the pod, is then when we look at the pod for Node app, it actually has a Dapr D. Let's see, and so and stuff that we have passed in here is some trust anchors for Sentry. These things should be delivered dynamically. I wonder if that's supported. Okay, and then bunch of args saying we do want to enable MTLS. And then let's see, we're getting the service account token. And then I wonder, does this actually have, does this go through and sort of muck with the, see, when we look at this container, all right, so here's the command Dapr D. Trust anchors, those are environment variables. Does this have any special permissions is the question. I don't think so. I think you should be able to do all sorts of fun stuff without that. Okay, cool. So that's up and running. This will deploy our Node.js app to Kubernetes. The Dapr control plane will automatically inject the Dapr sidecar into our pad. If you look at node.yaml, we see how Dapr is enabled for that deployment. So you say, hey, I want to opt in, and then this assigns a unique ID for the Dapr application, so it can be sent messages to and from and communicated with by other Dapr apps. I'm wondering, sort of like, okay, so, okay. You all see the container image we're deploying. This deployment provisions an external IP. We wait until the IP is visible. Okay, that probably won't work. Cube control get services. So it's going to be pending for a long time. But that's okay because we can actually just go through and do a port forward to the Node app, I think, probably. Yeah. And this is doing port 80 here. Okay. So we'll just do a kube control port forward Node app. Oh, we can do deployment Node app Dapr. And then what is the, I always forget the syntax here. Okay, we're going to do 80, 80 to 80. Okay. Deployment, control get. Oh, it's called Node app. There we go. So now if I go localhost, this page isn't working. Error forwarding to pod, port 80 to pod, blah, blah, blah. Failed to execute, port forward in network namespace. Can't connect. Connection refused. Okay, what am I doing wrong there? Okay, so this pod, like, what's the service? What's the service look like? So the service here for Node app, oh, there's Node app and Node app Dapr. This thing, oh, it's 80 to 3000. Okay. Oh, shoot, I closed my iTerm window. Damn it. Okay, there we go. We're back. We're back in business here. Let's see. I need to start Octane again. I need to do the port forward for Redis so that we can have that running in the background. Or, oh, it's already running. Jobs. PS. Is it running? Hi, Tomas from Sweden. How's it going, man? All right, so we do that. Oh, no. Okay, so what the? Yes. Okay, now we can do it. All right, that's running in the background. So now if we go to localhost, so Octane should still be running. There we go, cannot get slash. All right, so something's going on. We got to something. There we go. It's not exactly a great thing, but there we go. Okay, so to access it, once you have an external plane, you can save it, you can export a variable. Okay, so we got that thing. It didn't say to hit it with it. Next, look at our Python app. Python app with Kubernetes sample is this the Kubernetes sample. To quick glance at basic Python app to post JSON messages to localhost 35,000, which is the default listening port for Dapr. Okay, so you explicitly invoke with Dapr, so it's not like a service mesh where it tries to, like, you know, do all sorts of network magic to inject and grab stuff. We invoke the Node.js application's new order entry point by posting to blah. Okay, so this is v1 invoke node app. This is the name of the app that we're doing, and then method new order. And so this is essentially a sort of RPC bus that Dapr allows for. And so we're going to go through and we're going to do that. Oh, examples, cd samples 2. Okay, cd deploy. Oh, There we go. Finally got the thing created. Okay, so this is going to create that Python app, and it's going to do some stuff. Before this one has an ID of Python and Dapr IO is enabled, but it doesn't have the port here, which means that Dapr also does some stuff with that port. I'm not sure. Okay, now we can actually go through and we can observe messages coming into. Cool. Okay, successfully persisted state. So now if we do the Redis CLI localhost. Okay, so what is the is that -s? What is the, oh, all right. Get, oh, so now what is this? What did we say? It was order ID, got a new order. Okay, so can I actually sort of like, how do I list stuff in help? How do I list all the keys in Redis? Okay, okay, yeah, let's do that. Let's see what happens. Get star nil. So we don't have anything. Oh, get, oh, keys. Ah, I keep exiting. Keys star. Okay, so we have, oh, fascinating. So it has its own sort of key space schema. So I can do get node app. So magic is, okay, operation get, okay, so what is the type? Tell me what the type is. All right, but okay, so it's storing stuff into Redis, and let's see, and so what is the node app doing? So we, okay, yeah, curl, we can also curl node app order, curl localhost 8080 order. Okay, we're on 117 at this point. Sweet. We can clean up. Okay, I want to see the code for the node app. Where's the code? Oh, that's the Python app. So let's look, see what the node app is doing. So isomorphic fetch. I have no idea. This is the world that we're in. All right, so this is an Express app. There's a Dapr port that is an environment variable. We default to 35,000. And then we have our own state URL. So anytime we want to load or save state, I guess we do stuff to this URL. And then every time somebody goes through and says /order, we go through, we get the state, and then we return it. So if we fetch, so when we fetch order, okay, that's just going to return that. And then we post new order. Okay, so the fascinating thing here is that this is essentially providing, at this point, a generic face to a Redis instance. And then it's also providing a certain level of namespacing of Redis. And so like when you go through and we look what's actually happening behind the scenes here, the fact that it did the node app pipe order, it says that like you can have multiple things in Dapr all backed by the same Redis instance, and it'll actually provide namespacing along with the generic API, because I assume you could actually swap out from Redis to other types of key value stores instead of Redis. So that is sort of a great example of sort of like intermediating sort of like between you and a state store, providing some patterns that may not be as rich as Redis, but oh, type key. Okay, type. And this thing is hash. Okay, so I don't need help. What do we have? We have get the values of all the given hash fields. Is that what we want? HM get? No. Get multiple values. How do I get them all? HVals? Get all the values. Okay. HVals. Oh, that's interesting. Order ID 260. So it's writing two things in there. Why is it writing two things in there, I wonder? Where is that other thing coming from? State store name. So when we write new order, we're actually putting together this thing here. We're doing a post. Oh, you know what I bet you it is? I bet you it is. I bet you that's a version number of this thing. Ha, and it started at 0, whereas the order ID probably started at 1, something like that. Okay, so that's interesting. That's interesting. So I bet you there's some sort of versioning type of thing going on there for doing some sort of conflict. Okay, so now we can do a distributed calculator. Let's see if we can go ahead and do this one. So we're going to do a Go Mux application, a Python Flask application, Node Express, and a .NET Core application for subtraction. And then there's going to be state management on one of these things. Okay, this is kind of crazy. Sounds like fun. Okay, oh, we have to clean up this stuff. Cd deploy, git. Well, we'll leave. I believe we want to. We want to. Okay, cube control, delete. Okay, so now we want the Redis. I don't know. Does it actually? I was assuming that it would have me like recreate the Redis here. Yeah, because here there's another Redis, and so I'll just go ahead and redo that because I just want to make sure that I'm not like accidentally infecting one thing. So we have deploy here, redis.yaml. Okay, this is the exact same thing. So it is Redis master, and then the password is nothing. Here they're quoted. Do you see that? Okay. Follow these into Redis store, deploy everything, YOLO it out. Now I wonder if it's like cube control apply. I wonder if it's like order dependent. Like what happens if, because like the last thing I did was actually the state store. Can I actually like sort of like put the state store in there late? I wonder if that's something that it actually is good at. Okay, each service ending in Dapr reference your services related to sidecars, while the calculator front end service represents the external load balancer for these things. Okay, but we're not doing the external load balancer thing. We're going to actually sort of kill this port forward. And instead, we want this thing to be, what is it? Calculator front end is the thing that we want. There we go. Okay, and then these, all the Dapr things then are for communication between a bunch of things. Okay, so take the external IP address, and we can do localhost 8080. And this page isn't working. What did I do wrong? Oh, you know what? I bet you it's the wrong port. Let's look at Octant. We're going to look at the services again. The front end service is porting to 8080. Okay. So we're going to do 8080 to 8080. Boom! Check that out. All right, so now I can do 80 times 30, 2400. Okay, so that's magic. How hard could that be? Okay, so let's dig into what's actually going on here. Okay, open your browser console windows and see the logs produced as we use calculator. Know that each time we click a button, we see logs that indicate state persistence. Okay, so well, this is a React app. We are F12, so I don't have an F12 on this keyboard because this keyboard is very hipster. So developer tools. Oh, it says state store not configured. Why is my state store not configured? Is this an order dependent thing? Kill the pod and make sure the state is persisted. Okay, this is interesting. Oh, the port was missing in the Redis master. Oh yeah, you're probably right. Let's see if we can now. Redis master. What is the Redis port again? I always forget the Redis port. 6 379. Okay, does magic happen? So it's state store still not configured. Oh, I have to restart the pods? Okay. See, now this is actually an interesting thing. I think there is this aspect of sort of cloud native systems where, in my mind, you don't want this stuff to be order dependent, right? Because then you have to orchestrate how you actually roll this stuff out. Something like kube control applied doesn't know the dependencies that we talk about here. There might be some ways to actually talk about and express those dependencies in the YAML, but that's yet another thing to actually hook up. Let's see. So kube control get pods, kube control delete. Do I have to delete all of them? So how did you? I wonder. Okay, so I have to delete all the pods, just the calc. Okay. Calculator, delete pod. I could be like that person from the Reddit post where I can just like delete them all, just YOLO it. Okay. There we go. Or do I have to start? Oh, I have to restart the port forward. All right, there we go. Unexpected end of JSON input because, okay, there we go. Plus 2 equals. All right, cool. Here's the state. 8 times 6. So it's interesting that we're actually seeing the state come back here. I assume that, is this actually, is this coming from all the way from the client? And is the client saving that state? I wonder how that works. It's just the app returning. Okay, so all it's having server side in the app is just a relatively lightweight thing to that. Okay, cool. Maybe we could dig into the code clearly and see what's going on. Okay, and so now let's look at the app there. I definitely want to go refresh the page, take down the front end. Okay, so, okay, I want to read through that. But let's go through and let's look at the code for the app. So in this case, we're on 3. Let's see, which one is the app? Is a React calculator? Is this the client? Docker ignore Docker file. Oh, this is the server. Okay, the server. Okay, so when you do an add, you do that, request pipe to result. So then what do we return? So when you do a multiply, oh, okay, and then get state just goes ahead and gets the state, persist, forward state persistence to Dapr. Okay, so these things are essentially the client's driving it all, and the server is just being a proxy for the thing. We're serving client build and listening on the port. Okay, cool. And so what we do then is that whenever we do like a multiply, we take whatever the client gives us and we multiply app method multiply. So this is essentially a method dispatch where Dapr is actually doing the essentially point-to-point messaging stuff. Okay, cool. Okay, this sample demonstrates how we use Dapr as a programming model for simplifying the development of distributed systems. This sample Dapr is enabling polyglot, service discovery, and simplified state management. Each service in the sample is written in a different programming language. Service invocation. Yeah, okay, so this is what we were looking at. Okay, so essentially what it does is it creates a URL space for essentially doing RPC between services versus hitting the service directly. which means that the Dapr D that's running the sidecar that's running probably does a bunch of the retries and client-side load balancing and all that stuff. We're talking to localhost, and you just trust Dapr to be able to sort of maintain that. Okay, so it's both point-to-point communication here. It's also state storage and routing. Okay, yeah. And then transient fault handling and all that stuff is happening under the covers. So this is a lot of the stuff that, at least the non-state stuff, the point-to-point stuff, was a lot of stuff that you'll see in a system like Finagle. And then there's also pub sub and event bindings for similar things, which is really kind of clever. It's, I mean, it feels a lot like, at least the point-to-point stuff, feels a lot like of what you get out of a service mesh without all the sort of networking shenanigans that go on under the covers there. It's essentially saying the application itself has to buy into doing these things. And there's no reason that these applications can't call stuff outside of the Dapr world. I think the only question in my mind is, you know, when we look at the set of services that we have here, and we have something like the not the front end, but like, let's say that we have the, why is this not moving? Oh, I think it's just because my window's too small. That's kind of an Octant bug. Okay, but let's say the Divide app here. So the Divide app actually has a Dapr service for talking Dapr to that thing, and HTTP and this thing. And one of the things I'm wondering is that, is this protocol documented to the point where folks can call into Dapr without going through the front end? Could I write something that could talk Dapr directly? Or do I, you know, or are all those protocols essentially still mutable and sort of like specific to Dapr, right? And so I think one of the things that I'm thinking about is like, is there a way that we can think about Dapr being not just a runtime, but also a protocol for how I can actually talk to workloads in a more sort of in this higher level way? So that's something that I'm, and then also publish into the service discovery thing that Dapr, so that it's actually sort of works together. That's something that I think is interesting, because I'm always like, these things can be a little bit of a closed world type of thing. Okay, so this is doing very simple, and then we can do pub sub. Should we try and do one more before we run out of time? So pub sub, okay, we're using Redis as pub sub also. And let's see, this has multiple, I don't know if we're going to hit. Okay, so let's see what's going on here. This is going to that, and then runtime to the node subscriber. Should we try and give this a try? Let's try and give this a try. All right, so CD3, 4 dot, there we go. Okay, CD deploy, and let's go ahead and we'll copy our Redis here. Not going to make that mistake again. Oh, I don't want to do that. That would have been a mistake, because it turns out that now the type here is pub sub, and it's a message bus, and we can have that in addition to the state. So we're actually reusing the Redis host for that. If I'd copy and paste, I would have actually really broken stuff. I do want to copy and paste this though, so I don't get it wrong. Okay, so that's actually, okay, so that here we're actually seeing how this component is a more sort of generic thing with a type associated with it. Yeah, name is different and the type is different there. Okay, it wouldn't have broken, but yeah, okay, so it wouldn't have broken, but it wouldn't have worked either, because I wouldn't have had a message. Okay, now, and then we're gonna make we're not gonna make the same mistake again. We're gonna do kube control apply -f Redis. No, wait, what am I? Oh, kube control apply -f Redis. YAML, so we're gonna apply that first. And so that means, and then run locally, running Kubernetes. Dapr uses pluggable message bus. All right, this has like a Redis slave 0 and 1. I don't really need that. It should be fine with my like Hakorama Redis. Okay, and then this thing says, and this is wrong because that won't work with the, things may happen out of order because we're super fast. But we already did the Redis tune, apply-f. So we should be ready to go there. So we have blah, 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 React form. We're going to look at that service again, and we're not going to, there is some hack for kind that actually does support like type equals load balancer type stuff. Let's see. So we have the React form. This is the one we want. Okay. And this is going to 8080. Okay. What's it called? React form. Okay, cool. Okay, Evan's saying, what happens if you change the name of the pub sub to Redis type on the component? Does it break then? My guess is that well, I mean, this is a question. Is so like, if you have multiple state stores, how do you choose which state store to use? Is that something that is a all-up config of Dapr, or is it something that's on an application by application basis and there's an idea of like a default state store? Oh, the state store has the state store name in the API path. Oh, so when I actually hit these APIs, let's actually sort of look at that. So here our state store is called state store. Gotcha. Okay. And then when I look at, say, the node, or here the only thing that does it is the server.js. State store name is state store. Okay. Okay. That's nice. I like that. Okay. So now, okay, and then use the sample, React form, logs. Okay. Create and submit different message types. So we can go through and reload this. Message type A, B, and C. Hello there. Setting message 2, submit. Okay, and then, but yeah, so Evan's wondering if that's true for message bus also. My guess is yes, because I think if we look at the server here, publishing Dapr URL is, well, no. Publish. Okay, currently there's only one message bus per cluster. Enable it for multiple in the future. Okay, that's surprising to me. Okay, so, but it says that one of the things I can do is I can do logs. Cube. Node app listening on port 3000. Oh, that's a good question. The app scope doesn't have a Kubernetes namespace in it. And so that's something that's interesting too. I would expect, yeah, because that then you're going to have the problems like Ingress where it's like, hey, if I'm running in a multi-tenant world, I could actually go through and really node subscriber. So I don't see it show up in the logs. Let me make kube control get pods. Let me make sure I'm doing the right thing. Kube control logs. Didn't look like it worked. Oh, the node subscriber A and B, well, the Python does A and C. So, test. Let's try the Python subscriber. Oh, if this is Redis 5, it won't have Redis stream support, so maybe Redis is busted. I don't know. There's got to be a help. Get Redis version command. No. Info. Redis version 2.8.19. Okay. So that's the problem that we got here. We're, okay. So if we had a more up-to-date version of Redis, this would work. Yeah, it's ancient. I don't know where it came from. I think it's used in the Kubernetes end-to-end tests. That's hilarious. Okay, so yeah, so don't use an ancient version of Redis, which is probably has like huge security holes also. But okay, but you can subscribe, and the fact that, okay, so yeah, a couple of feedback based on what Evan said is that, like, the fact that I like that the state stores are segmented. I don't like the fact that you don't have multiple message queues, and I don't like the fact that the application names are global across all these things. Okay, switch to another. I'm going to run out of time, so doing something like nats would be interesting too, for sure. Yeah, the Kubernetes guestbook example. It's so ancient. But yeah, one of the things that that I think, and this is something that I definitely look at when I look at these things. There are definitely places where this works with Kubernetes. I like the fact that, like, Redis, that Dapr uses Kubernetes services to talk between things. I like the fact that we're using CRDs for configuration. I think these things are simple enough. We could probably get away with config maps here. These things really aren't operators in terms of like managing CRDs with spec and status, right? It's not like a controller pattern like that. It really is about the injection and providing a meet me point. Things I really don't like is that this totally ignores the Kubernetes namespace model, right? And so there are no protections for, hey, I'm running something in one namespace and I want to run something in another namespace. Dapr installs globally, and then all of a sudden you have this space, and I'm not sure, and I haven't seen, is there support with Dapr for actually having any sort of identity in ACLs to actually say, well, only this namespace can actually use this application name, and this thing's allowed to actually see this data or talk to this data, or this state store is only available in this type of thing. So that's sort of like, yeah, well, globally with respect to the cluster, right? And I think, and that also actually begs the point also. So you say you don't do cross namespace communications. Okay, so does that mean then that the state store is not cross namespace also? So does that mean that, like, if I launched, okay, so that's interesting then. Okay, so there is no cross namespace communications then. Okay, that means that in terms of yeah, I know we could test. I'm running out of time, Evan. I mean, because like in my mind, it's like if I'm doing microservices, there's different sort of schools of thought. I think a lot of folks want to have, you're going to end up with this web of services, some things in some namespace, some things in another, and actually even having these things cross-cluster. So understanding sort of what is the tenancy model, how does it relate to namespaces and multiple clusters, that's super interesting. Clearly that has knock-on effects with respect to the way that certificates are managed and you secure communications, because if you start doing cross-cluster, cross-domain type of thing, you have to start worrying about providing unique names and stuff like that. Okay, so you can create a state store for apps from several namespaces, or you can deploy them in the same pod or per namespace. Okay, so the state stores are global. That namespace is global, but yet the names of the applications is per Kubernetes namespace. So you can see some of my confusion here. So understanding the tenancy model and where things are namespace specific versus not would be really interesting to me. That and the ability to actually talk about, okay, what is this as a system, and then what are the individual protocols, so that, like, I think, can people actually, without using Dapr, the system, start interfacing with Dapr workloads, and Dapr services at a higher level? I think that would be really interesting to me also. And I think, and when I look at these things, that starts to provide ways for these things not to just be sort of this bubble of a closed system, but also to be things that can interface with other systems in really interesting ways. And it also starts to provide the capability for, say you have a monolith, you're breaking it down, you can import a library that allows you to interface into Dapr, and now you can talk natively to Dapr, maybe without a sidecar, maybe off cluster even, and then translate that stuff as you go. Whereas as things are right now, it has that aspect of service meshes where you're either in or you're out. And if you're outside the service mesh, then you need some sort of gateway. And so with Dapr, you would need some sort of gateway like that, the node thing, and with the React apps on the back, that actually has some sort of domain-specific proxying into the Dapr world. And so that's the type of thing that I think would be interesting here. But overall, and then, okay, so that's pub sub. If we'd gotten that to work, bindings, these are ways, okay, so this is really interesting where you're both talking to Kafka. I assume this starts to look a little bit like dependency injection, maybe. Or no, this is bindings for events. Okay, this is the other thing that I think is interesting here, is that one of the nice things about Finagle is that they actually have this way of being able to rewrite names and do dependency injection. And so you could say that, hey, I want to send a message to service foo, but you could have foo be actually some sort of mapping that says, well, foo really is implemented by foo version 23, and we have foo version 24 over here, and then you can actually do a traffic split based on that service mapping. And so thinking about the target namespace for either an event binding, or whether you're talking about targeting a microservices being something that comes out of a virtual namespace that is different from what the app identifies itself as, I think is also an interesting thing, and something that's worth looking at something like looking at something like Finagle for some ideas there. And then this is Azure Functions and Kata to provide, yeah, okay, I'm not going to dig into that. And then there's middleware with OAuth 2 enabling. So this is, okay, SIPs. Okay, so I love that it uses a Google account as an example, considering that, y'all work for Microsoft. That's hilarious. So we have an app container. So what is this doing? So this is actually IP of your ingress. So we're doing ingress here. I don't have time to actually go through this, but we have an OAuth 2 middleware. Now, is this middleware actually implemented by Dapr? Yeah, I don't have time to actually go through this. So we have an Echo app and an ingress. And I'm just wondering, deploy OAuth 2 file. Okay, and it just forwards everything on then, I guess. Separate repo for components. Okay. So you can chain components. Some of them are middleware. Okay, so now are these things actually separate pods, or are these things components that are all built into Dapr? I guess that's the question. And I guess what I can do is I can look at the deployment here. OAuth 2, this is middleware. Okay, so this is a component, gotcha. And this is a set of capabilities that are built into Dapr, and you activate them, gotcha. Okay, this is different from something like thinking about this as being an extensibility mechanism. Okay, and then you can build your sidecar with components of your choice. Okay, so that's an interesting thing. So you may actually end up building your own Dapr. Does that sidecar run next to Dapr, or does that sidecar? Yeah. Okay. Something worth looking at. Okay, so the middleware stuff is super interesting also. in terms of being able to actually sit in here. Okay, it is Dapr D. Okay, so you'd have to build your own version of Dapr D with the middleware that you want to be able to actually make this stuff work. Okay. Cool. All right, so that is super interesting. What are, I guess my last question here is, when we start looking, so we did PubSub, we looked at event bindings, we looked at some of the middleware, there's like RPC types of stuff. You can do something with Kafka where you actually come together. Are there any patterns also going on? Because I think this is something that is interesting. This is like Cloud State builds on top of Akka, and Akka has a bunch of doing things like does some advanced sort of like state merging types of things where it's like you want to do, what is it? It does, I always get the acronym wrong. CDRTs or whatever it is, right? Okay, Dapr has cloud state integration released yesterday, so that's really interesting. Okay, because I think so. It's a little bit of a different sort of take on it because cloud state is really about, from my understanding, I haven't played with it, is really about more advanced patterns for actually dealing with distributed data patterns. Where it looks like Dapr is really about providing a more instrumented runtime for communication that is at the sort of application involved level versus being involved at the sort of networking level with service meshes, which is actually really cool. Okay, you can save cloud state CRDTs using Dapr, so you have an in-memory replicated database with Dapr and cloud state. Very cool. Yeah. Okay. Very cool stuff. Okay, I've gone over, so it's just like an hour and 40 minutes. Thank you, Yaron, so much for joining and answering my stupid questions. Thank you for everybody else for sticking with me through this. You know, a little bit of a dust up there with getting Redis up and running. I apologize for that, but I think we all learned something like don't run 4-year-old Redis. And so with that, I'm going to wrap it up. Thanks for joining me. I'm not sure who's exactly going to be, what we're going to be doing next week on TGIK, but we'll come up with something fun, and I'll get my fancy new microphone working perhaps. But everybody have a great weekend, and we will see you next time. Thank you so much.